Why do off-by-one errors happen when handling loop boundary conditions? Imagine trying to count the number of candies in a jar but accidentally counting one too many or missing the last piece. That's similar to what happens with off-by-one errors in programming. These errors are common when working with loops and can be tricky to spot. They happen because of how we set the start and end points of a loop. If we include or exclude the boundary incorrectly, the loop might run one time too many or too few. Most programming languages use zero-based indexing, meaning the first element in a list is at position 0. If you forget this and treat the first element as 1, your loop might go beyond the actual data or stop early. For example, if you want to go through an array of 10 items, the correct loop runs from 0 to 9. But if you accidentally write it to go from 0 to 10, it tries to access an element that doesn't exist, causing errors. Another common cause is the fence post problem. Think of building a fence with posts. If you count the posts and the spaces between them, it's easy to get confused about how many times to run the loop. Counting the posts might give you one number, but counting the spaces between them might give you another. If you don't match your counting method with your loop, you end up with an off-by-one mistake. These errors are often subtle because they don't cause crashes right away. Instead, they produce wrong results, like missing data or extra iterations. Sometimes they lead to accessing memory outside the array, which can cause crashes or unpredictable behavior. To avoid this, it's best to carefully define your loop boundaries. Decide if your loop should include the start or end index, and stick with that rule. Using half-open intervals, where the start is included but the end is not, helps keep things clear. It's also helpful to test your loops with small examples or edge cases. For example, try looping through an array of 1 element or 0 elements. This way, you can see if your loop runs the right number of times. By paying close attention to how you set your boundaries and testing thoroughly, you can prevent off-by-one errors and make your code more reliable.